Known to millions simply as Dory, the blue tang fish is far more than a colorful side character drifting through coral reefs. Behind its vivid blue body and seemingly carefree movement lies a complex organism shaped by millions of years of evolution, finely tuned to survive in one of the most competitive and fragile ecosystems on Earth. Scientifically classified as Paracanthurus hepatus, the blue tang is a reef-dwelling fish whose life is governed by memory, spatial awareness, social signals, and constant negotiation with danger. It is a creature that survives not by brute strength or speed alone, but by knowing exactly where it is, where it has been, and where safety lies. The evolutionary roots of the blue tang trace back to the family Acanthuridae, commonly known as surgeon fishes. This lineage emerged as coral reefs expanded across tropical oceans, creating dense, structurally complex habitats that rewarded precision over power. In these environments, fish that could maneuver efficiently, recognize landmarks, and exploit narrow ecological niches thrived. The blue tang evolved alongside reef-building corals, its body shape and behavior molded by labyrinthine coral structures and shifting currents. Over time, natural selection favored individuals capable of rapid directional changes, strong sight fidelity, and an acute awareness of their surroundings. Physically, the blue tang is instantly recognizable. Its body is laterally compressed, allowing it to slip effortlessly between coral branches and rocky crevices. The intense cobalt blue coloration, contrasted with a bright yellow tail and black markings, is not random beauty but a functional signal system. In the filtered light of shallow tropical waters, blue wavelengths penetrate efficiently, making the fish visible to members of its own species while blending into the complex visual noise of the reef. This coloration also plays a role in social recognition, allowing blue tangs to identify one another within mixed species schools. One of the most distinctive anatomical features of the blue tang is the sharp, scalpel-like spine located on either side of its caudal peduncle. This structure, which gives surgeonfish the common name, is a defensive adaptation rather than an offensive weapon. When threatened, the blue tang can flick its tail sideways, exposing the spine and delivering a swift slash to deter predators. The spine is sharp enough to inflict serious injury, making even larger predators think twice before committing to an attack. This single adaptation dramatically increases survival odds in an environment where escape routes are limited. Behaviorally, the blue tang is a master of routine. Individuals establish home ranges within the reef, memorizing specific routes, feeding grounds, and shelter locations. This spatial memory allows them to move efficiently through their environment, minimizing exposure to predators. Contrary to the myth of forgetfulness often associated with the name Dory, blue tangs rely heavily on memory to survive. Losing track of safe refuges or feeding zones would be fatal in the dense and predator-rich reef ecosystem. Blue tangs are primarily diurnal, active during daylight hours when visibility allows for precise navigation and feeding. They spend much of their time grazing on algae growing on coral surfaces and rocks. This herbivorous diet places them in a critical ecological role. By controlling algal growth, blue tangs help prevent algae from overwhelming coral colonies, which would otherwise block sunlight and inhibit coral growth. In this way, the blue tang is not merely a resident of the reef but a caretaker, contributing directly to the health and resilience of the coral ecosystem. Feeding is not a solitary act for the blue tang. Juveniles often form schools, gaining protection through numbers while learning the layout of the reef. Adults may also school, particularly when feeding or migrating short distances within the reef system. These social groupings reduce individual predation risk and increase foraging efficiency. Communication within these groups relies on subtle body movements, color changes, and positioning rather than vocalizations or aggressive displays. The habitat of the blue tang spans the Indo-Pacific region, from the eastern coast of Africa to the islands of Micronesia and the Great Barrier Reef. It inhabits shallow coastal reefs, lagoons, and outer reef slopes, typically at depths ranging from 1 to 40 meters. These environments are dynamic, shaped by tides, storms, and seasonal changes in water temperature. The blue tang's adaptability allows it to persist across this wide range, provided that coral structures and sufficient algal food sources remain intact. Reproduction in blue tangs follows a pattern common to many reef fish but executed with remarkable precision. Spawning typically occurs in groups during specific lunar phases, often at dusk. Males and females release sperm and eggs into the water column, relying on synchronized timing to maximize fertilization success. The fertilized eggs drift with ocean currents, becoming part of the planktonic community. This dispersal strategy allows blue tang populations to colonize new reefs and maintain genetic diversity across vast distances. The larval stage is one of the most vulnerable periods in the blue tang's life. Tiny, transparent, and largely defenseless, larvae drift for weeks before settling onto a reef. Survival during this phase depends on ocean currents, temperature stability, and sheer chance. Those that survive undergo a dramatic transformation, developing their iconic coloration and reef-adapted body shape as they transition into juvenile life. This high-risk, high-reward reproductive strategy has sustained blue tang populations for millions of years. Despite their evolutionary success, blue tangs face increasing threats from human activity. Coral reef degradation caused by climate change, ocean acidification, and pollution reduces available habitat and food sources. Rising sea temperatures lead to coral bleaching, transforming vibrant reefs into barren structures incapable of supporting diverse fish communities. Additionally, the aquarium trade has placed significant pressure on wild blue tang populations, as their striking appearance makes them highly desirable ornamental fish. In response to these pressures, conservation efforts have begun to emphasize sustainable reef management and responsible aquarium practices. Research into captive breeding has shown promise, reducing the need for wild-caught specimens. Marine protected areas also play a vital role in preserving blue tang habitats, allowing reef ecosystems to recover and maintain their ecological functions. The blue tang's role in the reef ecosystem cannot be overstated. As an herbivore, it helps maintain the delicate balance between coral and algae. As prey, it supports larger predators, contributing to the energy flow within the reef. Its presence is an indicator of reef health. Where blue tangs thrive, reefs are often structurally complex and biologically rich. Where they disappear, imbalance soon follows. What makes the blue tang truly remarkable is the quiet intelligence embedded in its daily life. Every movement reflects learned experience, every feeding route a memorized map, every retreat into coral a calculated decision. It is not a fish drifting aimlessly through the sea, but a navigator of a three-dimensional world shaped by memory and instinct. As coral reefs face an uncertain future, the fate of the blue tang is inseparable from the fate of the ecosystems it inhabits. Its story is a reminder that even the most visually simple creatures are the product of deep evolutionary history and intricate ecological relationships. In the shimmering light of tropical seas, the blue tang continues its ancient routine, weaving through coral corridors with purpose, precision, and a memory far stronger than its reputation suggests.